With discriminate in hand, we now have the tools, we're now equipped to reason about inequalities, proofs that things are not equal. So let's start with a classic theorem, general fan favorite, that 0 is not equal to 1. It is, and really what that means in cock is it is not the case that 0 is equal to 1. Let's do the proof. So we have all the tools we need. The first thing I want to note is like, look at that notation. So I used this earlier and I said, oh, we'll meet this in a video or two. We'll see what this means. And this is the same thing. So this is just saying this, right? Notice what we wrote. Cock always prints things using the notations that it has. Okay, fair. So a thing to remember is that whenever you see this inequality, that's really meaning this. It's a not. So the thing you want to do is unfold that not. Right? That's just the way to treat negations. Now, you don't have to unfold it, but I think it's the right way to go. Okay, let's see what happens. Now we say, okay, 0 equals 1 implies false. Okay, suppose that 0 equals 1. Get out of town. What are you talking about? No, absolutely not. Not today. Not any day. Now, just to hammer home my point, you don't need that unfold not. You can just do the intros, right? Because like cock sees right through the definition of not and says, oh yeah, that inequality, that like this symbol here, this is the same as this, and this is the same as 0 equals 1 implies false. So you can intros it, it's an implies, right? Under the hood, this is really just an implication. And Cox sees that, so intros will work on it. That's one of the things intros does. Uh, if you're not comfortable with that, that's fine. Just unfold it first. There's no like penalty for unfolding, right? If you know to do it, you'll save time. It's just like less to do, and saving time is nice, but kind of whatever. So intros contra, and boom, as they say. Okay, so this is the way that I would prove it, right? I would write it just with the inequality, and I would say, okay, great. Suppose for a contradiction that 0 is equal to 1. It isn't. That's all I have to say. Okay, now negation in cock is basically just awkward, right? If you've used proof, if you've done proof in other disciplines, particularly in math, negation is not as difficult for reasons we'll address later. I hinted at this back when we talked about the false and negation propositions. I want to give you just like a quick example, two versions of a quick example of like how to reason about these inequalities. It is just always less nice. And if you can state something positively in cog, your life will be much better than if you state it negatively in terms of using a negation or whatever. Okay, so in particular, what I want to show is the principle of explosion, ex falso quod libet, is particularly useful for inequalities. Let me show you. So here, this is a kind of like a disjointness theorem on some level. If B isn't true and B is a Boolean, then B must be equal to false. Okay. Hopefully you believe this, right? There's really only two Booleans, true and false, and if you're not true, then you got to be the other one. Let's see how the proof goes. Okay. Let B be given such that B is not equal to true. Okay, by cases on B, I'm going to not do the equations or anything. We're just going to be fine. So the first case we're in is the B equals true case. So we know that true is not equal to true, and we need to show true is equal to false. If you're confused, I don't blame you. This is backwards. What is he talking about? Right? True is not equal to true, but we need to show true is equal to false. Remember, stay calm. It is concerning to have a proof goal that is not true, right? We know that true and that is not correct. That is not provable. Sorry, confusing when we're talking about Booleans. Right? You might be worried when you see true equals false is my goal. I'm never going to get there. It's like, well, you're right. We'll never be able to positively prove that true is equal to false. But look at what we've assumed. We've assumed that true is not equal to true. And like, we know that it is. True is definitely equal to true. That's like reflexivity, guys. Okay, so how do you do it? How do you get this proof to work? There's different ways of doing it. What I'm going to show you is, I think, sort of the nicest. When you have a false inequality, right, an inequality that is not correct in your context, the recipe is basically use ex falso quod libet and then blow things up. Let me show you how. Okay, first, let's remember what that equality really means. It's saying true equals true implies false. But like, we can prove true equals true, which means we can prove false. And you're not supposed to be able to prove false, which means we're in an inconsistent world. So great. We have an impossible goal, but we're also in an impossible world. Okay. So how do we make use of this? The easiest thing to do is to say, I'd like to change my goal, please. And ex falso quod libet says false implies anything. Right? For all P, false implies P. What that really means is you can apply this whenever you want, and it'll just change your goal to false. Now, false is unprovable, so you only want to do this when you're in a crazy world, when you're in a context that's sort of got contradictions in it. But we are. Look, H shows that true equals true implies false. So apply H. Now all we have to do is prove true equals true, but we can do that. This process of applying the principle of explosion and then proving something is our way of saying, hey, we've said something isn't true that really is. Right? H is a ticking bomb that says if you can show true equals true, the whole world explodes. So we can prove true equals true. So we can blow up the world and not have to deal with this crazy case. If that didn't make sense, I recommend running through it one more time. Just watch that bit of video again. Okay. Let's look at the next case. Now our goal is we assume H, false, is not equal to true, and we have to prove that false equals false. Well, proving false equals false is really easy, right? We don't have to think about that one. How did this proof go? Let me read it out loud to you. For all booleans b, if b is not equal to true, then b is equal to false. Okay, let b be given such that b isn't true. Now we know that b isn't true, but we don't know what b is. So let's go by cases on b. The first case is that b is equal to true, but we just assumed that b is not equal to true. So absolutely not. Okay, that was a very short English sentence for a lot of reasoning in cock. This is what I said when reasoning about negation in cock is annoying, right? A simple notion, hey, look, buddy, we assumed that b isn't equal to true, but now we're in the case where b is equal to true, get out of town. That takes a little more to say in cock. The get out of town, they got to pack their bags and everything. Now, alternatively, we're in a case where b is equal to false, but that's great. That's what we needed to show. If b isn't true, then b is equal to false. No big. Okay, this is a common enough thing that in fact cock provides a tactic ex falso, so you don't need to prove a lemma like ex falso quod libet. You can just use that tactic ex falso. Kind of whatever. Up to you which one of these you do. I just want you to know about it. It's a nice shorthand. Okay. In the next video, we're going to learn about yet another kind of proposition. I know. It's marching on. After this, and then after, like, we have one or two more important things we'll learn about propositions, and then we'll back off that for a while. But we are just kind of building up our toolkit of things we can say about the world. So please bear with me. Talk to you soon.